Okay, folks, this is the final lesson of our prerequisite unit in regular geometry at Speedway High School. Here we are going to discuss how to solve a linear equation that contains fractions. Basically, we're going to take what we were previously doing, which involved distributing to get rid of parentheses, then adding like terms on each side, then getting the variable by itself and dividing, solving a two-step equation. That's how we've been solving equations all along. But now we're going to throw a step on the beginning because our equation is either going to contain fractions or decimals. And the way that we deal with that is we simply determine what that least common denominator would be, or LCD. Then we multiply every term by the LCD. What this does is it causes those fractions to turn into integers because the denominators of the fractions will cancel into that LCD. We're allowed to do this because we're multiplying both sides by the same value, which keeps the equation nice and balanced. So here's an example. It's a pretty easy one. All three of these fractions are over 13. So our LCD for 13, 13, and 13 is 13. So what we do is we're going in here and we're multiplying each term by 13. Again, what we've done there is we've multiplied the left side by 13 and the right side by 13, which mathematically is 100% legal. When we do that, the denominators and the numerators will divide. So 13 divided by 13 is 1. 13 divided by 13 is 1. 13 divided by 13 is 1. And then we're going to multiply those numbers on the outside times what's left on the inside. That would give us the expression, the equation, b minus 3b equals 8. From there, we're treating this like any other linear equation. There are no parentheses. We're not going to see that till later in the lesson. So we don't need to distribute. We move to combine like terms. We have a 1b and a negative 3b. So we add those together. That's negative 2b equals 8. And then we divide by negative 2 to get b by itself, giving us our answer, b equals negative 4. Let's look at a harder one. So here's a couple that are going to take a little bit more thought. The first one here has denominators of 5 and 10. So we need to think, what's the LCD of 5 and 10? Well, that would be 10. Okay? So we're going to do 10 times n over 5 minus 10 times 3n over 10 equals 10 times 1/5. Now when we do that, what happens is we have to go through and divide. 10 divided by 5 is 2. 10 divided by 10 is 1. 10 divided by 5 is 2. Then we're going to multiply 2 times n, negative 1 times 3n, 2 times 1. That would give us 2n minus 3n equals 2. Just like the last one, no parentheses, so we move on to combine like terms. 2n minus 3n is negative 1n equals 2. And then we divide by negative 1 to get our answer. Negative 2 divided by negative 1 tells us that n is negative 2. On the next example, we need to be very careful because if you notice, we have two fractions and a whole number. But we need to remember that whole numbers can easily be written as fractions. We just write them over 1. So we're looking for the least common denominator for the numbers 4, 1, and 8. That would be 8. The first number that is divisible by 1, 4, and 8 is 8. So we would do 8 times x over 4 plus 8 times 7 over 1 equals 8 times 5 over 8. We go through and we divide. 8 divided by 4 is 2. 8 divided by 1 is 8. I know that didn't change. 8 divided by 8 is 1. Multiply those numbers would give us the expression 2x plus 56 equals 5. We would then solve this two-step equation by subtracting 56 from each side, which gives us 2x equals negative 51. And then we would divide by 2 which gives us x is negative 51 over 2. We do not want to give a decimal here. We want to give a fraction, and we have to check to make sure that fraction doesn't reduce. 51 is odd, so it is not divisible by 2, meaning that does not reduce. Let's do a couple more. Okay, so we're going to go a little bit faster on this page. Again, we're trying to find the LCD of the denominators. We have the denominators 5 and 15. That would be 15, would be the LCD. So we do 15 times 1/15 plus 15 times 4x over 5 equals 15 times 3/5. We then go in and do our division. 15 divided by 15 is 1. 15 divided by 5 is 3. 15 divided by 5 is 3. Multiply. Those red numbers times the blue numbers would be 1 plus 12x equals 9. And then we solve that equation. So we would subtract 1 from each side. Would give us 12x equals 8. And then we divide by 12. 8 is not divisible by 12, so we have x is 8 over 12. That fraction does reduce. The top and the bottom are both divisible by 4. So we are expected to realize that and reduce the fraction to 2/3. X is 2/3. Let's get that in an acceptable color there. Okay, I guess I'm going to have to erase it to get it in a correct color. X equals 2/3. Okay, x equals 2/3 is our answer. On the next problem, we have two expressions that need to be written as fractions. So we're looking for the LCD of 1, 3, and 9. That would be 9. So 9 times 2/3 plus 9 times n over 1 plus 9 times 6 over 1 equals 9 times 7 over 9. Go in and do the division. 9 divided by 3 is 3. 9 divided by 1 is 9. 9 divided by 1 is 9. 9 divided by 9 is 1. Multiply. Gives us the linear equation 6 plus 9n plus 54 equals 7. Combine like terms would be the next step. 6 plus 54 would be 9n plus 60, equals 7. That's a two-step equation, so we would subtract 60 from each side, which would give us 9n is negative 53. Divide by 9. 53 is not divisible by 9. 53 is actually a prime number, so that fraction does not reduce. We cannot divide the top or the bottom by the same number, so it does not reduce. One more. Here we are looking for the LCD of 3, 6, and 9. The first number that is divisible by all three is 18. So we would do 18 times 1/9 equals 18 times 5/6 minus 18 times m over 3. Division. 18 divided by 9 is 2. 18 divided by 6 is 3. 18 divided by 3 is 6. Then we do the multiplication. That would give us the equation 2 equals 15 minus 6m. That is a two-step equation, so subtract 15 from each side, which gives us negative 13 equals negative 6m. Divide by negative 6. 13 is not divisible by 6. However, negative divided by a negative is a positive, so our answer would be the non-reducible fraction 13 over 6. Okay, Now, what if there are parentheses in the equation? Well, that doesn't change a whole lot. Pretty much, if you have parentheses in a problem and there's a fraction out in front of those parentheses, you can still clear the fraction the same way we've been discussing. The one thing you need to do is ignore everything on the inside of the parentheses until you clear the fractions. So you do not multiply the numbers inside the parentheses. Okay? So here's some examples. You'll notice that we have two fractions, 3/5 and 1/5. So our LCD of 5 and 5 is clearly 5. So we do 5 times 3/5, and we completely ignore the fact that there's an x plus 4, and 5 times 1/5. Divide. 5 divided by 5 is 1. 5 divided by 5 is 1. Multiply. Gives us the expression without fractions. 3 times x plus 4 equals 1. From there, we would solve that equation like every other one we've done. We would distribute the 3, which gives us 3x plus 12. 3x plus 12 equals 1. Subtract 12 from each side. Gives us 3x is negative 11. Divide by 3. And we get x is negative 11 over 3. Let's do another one. Over here we have 3 fractions, meaning we're looking for the LCD of those 3 fractions, which is 3 and 9. The LCD would be 9. So we do 9 times 1/9 equals 9 times 2/3 times the parentheses, which we're ignoring, plus 9 times 7/9. Cancel. Divide the 9s. 9 divided by 9 is 1. 9 divided by 3 is 3. 9 divided by 9 is 1. Multiply. Giving us the expression 1 equals 6 times x minus 5 plus 7. Distribute the 6. Gives us 6x minus 30 plus 7. Combine like terms. Gives us 6x minus 23. Add 23 to each side. Gives us 24 equals 6x. Divide by 6. Gives us x equals 4. Okay, that does it for clearing the fractions. Thank you for your attention.